Today we're looking at solving polynomials in factored form, and in order to do this we need to know the zero product property, which says if a and b are real numbers, if a times b equals 0, then either a equals 0 or b equals 0. So if we think about this, say a was 4, right? If we wanted to take 4 times something and have it equal to 0, the only way that can happen is if b is 0, right? Because 4 times anything else would not be 0. So this is just one example, right? And that's what the zero product property is saying. It's saying if you're multiplying and your answer is 0, then one of your factors has to be equal to 0, because that's the only way it can multiply to 0. So we want to solve using the zero product property. So for letter A, we have our factored form, x plus 3 times x plus 2 equals 0. Now in the past we've multiplied these out, but we actually want to leave this in factored form, because our zero product property tells us that if we have some factor A and we're multiplying it by some factor B and our answer is 0, the only way that that is going to be true is if either our factor A is equal to 0 or our factor B is equal to 0. So we have two options that could make this polynomial make sense, or make this equation make sense. Either x plus 3 equals 0, in which case if we solve for x, we can subtract 3 on both sides and find that if x equals negative 3, then that first polynomial would equal 0. And our second option is if x plus 2 equals 0, in which case we can subtract 2 on both sides and we get x equals negative 2. So we find that there are two x values that would make this equation be true, that would make it make sense. So looking at letter B, we're going to do the same thing. If we have x minus 7 times 2x minus 7 equals 0, the only way that that can be true, the only way it can be equal to 0, is if x minus 7 equals 0, or if 2x minus 7 equals 0. So if we know that, we can just solve for x. That's our job here, solving for x. So x could be a positive 7, or right, if we add 7 on both sides using our inverse operations, we get 2x equals 7, so we can divide by 2 on both sides, and we see that x could be 7/2. So x is 7 or x is 7/2. Those are the only two numbers in the entire world that could make this polynomial be true. And just as a side note, if you wanted to check your answer, you could. Right, when we say it could make the polynomial be true, we're saying that if we plug 7 in to that polynomial for x, this is what would happen. 7 minus 7 is 0. 2 times 7 is 14 minus 7. Well, 14 minus 7 is just 7. And 0 times 7 is 0. So we find that 0 equals 0. So that's what we're saying is happening, right? That's what we're solving for. We're solving for the x value that would make the polynomial equal 0. Let's do a couple more examples. So we want to figure out what values of x will make the statement true, right? What value of x would make 3x minus 5 times x minus 2 equals 0? And since we have two factors, we're going to have two answers again. So we have a situation where 3x minus 5 equals 0. So we can add 5 on both sides, and we get 3x equals 5. And then we can divide, so we see that x could be 5/3. That is one of our answers. We also have where x minus 2 equals 0. So we can use our inverse operations to add 2 on both sides, and we see that x could be a positive 2. Those are the two x values that would make that polynomial true. Letter D, we have 8x times 3x minus 2. Well, again, we still have two factors. 8x is a factor, and 3x minus 2 is a factor. So in order for this to equal 0, either 8x could be 0, or 3x minus 2 could equal 0. And then we just solve. We could divide by 8 on both sides. So we see that x equals 0 is one x value that would make this polynomial or this equation true. And then we could add 2 on both sides. We'll get 3x equals 2. So then when we divide by 3, we see that 2/3 is the other x value that would make this equation true. Let's just do a couple more examples here. Solve by factoring, right? Again, these are already factored, so it would be a good idea to pause the video and see if you can solve this or finish this for yourself. Right, all we need to do, if we're taking x plus 2 times x minus 4 and we want to solve for x, we're going to set each factor equal to 0. That's our only job here. So if x plus 2 equals 0, then we can subtract 2 on both sides, and we see that x could be negative 2, or x could be positive 4. Notice how the signs flip, right? When we had x plus 2, our answer was negative. When we had x minus 4, our answer was positive. That should always happen when you're solving because of your inverse operations, right? If you were adding in your factor, your answer should be negative. If you were subtracting in your factor, your answer should be positive. So those signs will always flip. Looking at letter F, 2x minus 4 times x plus 6 equals 0. Well, again, we're going to do the same thing. That means either 2x minus 4 equals 0, in which case we can add 4 to both sides, so we get 2x equals 4. 4 divided by 2 leaves us with x could be 2. That's the next value that would make this equation true. And then we could take x plus 6 equals 0. If we subtract 6 on both sides, we see that x equals negative 6. Those are the only two numbers that can make this a polynomial work out. All right, last couple here. Letter G. 2x plus 1 squared equals 0. Remember that 2x plus 1 squared literally means we have 2x plus 1 times 2x plus 1 equals 0. So again, we're going to take each factor and set it equal to 0. 2x plus 1 equals 0. So then when we solve, we can subtract 1 on both sides. So we get 2x equals negative 1. And then we can divide by 2. So we get x equals negative half. Now, notice that these were the exact same factor, right? 2x plus 1. Since they're both 2x plus 1, that means when we solve them, we're going to get the same answer. So if you want to be formal about it, this is technically an equation with a root of multiplicity 2 because it's got the same answer twice. Okay. But if you recognize, right, if you recognize that they are the same factor, you really only need to solve it the one time. And then letter H, we have 3x times 4x plus 2 times 3x minus 9 equals 0. So we have 1, 2, 3 factors. So since we have 3 factors, we're going to have 3 solutions here. We have the solution where 3x equals 0, in which case we can divide by 3, and we see that x equals 0 would make this equation true. Then we have our second factor, 4x plus 2 equals 0. Well, we can use our inverse operations, right, to subtract 2, and then we'll divide by 4. And we see that x equals negative half. That's the second number that can make this equation true. And then last but not least, we could have 3x minus 9 equals 0. So we could add 9 to both sides, leaving us with 3x equals 9. And then when we divide by 3, we see that x could be a positive 3. And those are the 3 factors, or 3 numbers that could make this equation true. And that is how we solve for x in factored form.